You can't keep me down. 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 Down, 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 down.
Fuck the media posing as experts. Fuck the radio. Fuck the television networks. I'm not apologizing, I don't care what the cost is. Go ahead, corporations, you can take back your endorsements. Fuck the media posing as experts. Fuck the radio. Fuck the television networks. You could murder me before I let you take control.
My mind is my own and I trust in my soul. You can't keep me down. 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 My mind is my own and I trust in my soul. You can't keep me down. You can't keep me down. Down. You can't keep me down. You can't keep me down. Down. You can't keep me down. You can't keep me down. My mind is my own and I trust in my soul.
Jimmy, the second tower just went.
The towers didn't burn up, nor did they slam to the ground. They turned into dust in midair, 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 midair.
We're going to look at some other things about the weird fires. I can't call them regular fire because I don't know that. The weird fire, just to note that it's not something that you know for sure what it is. It's glowing, but the paper doesn't seem to burn. If this was glowing because it's hot, it'd have to be at least, 1,200 degrees centigrade. Aluminum melts at a little over 600 degrees centigrade. It's not a puddle. This aluminum is not a puddle, so how hot can it be? And this igloo cooler and the plastic trash can are not melted. The paper is not burned either on the ground. So what is that color? And another weird thing about this, right across the street over here is the Burger King. And inside they're flipping burgers, cooking burgers for the firefighters. Not serving to the customers, and then the building across the street was missing. It's just a weird sight. Now this van is also interesting that, you get all this something looks like it's on fire, weird fires there. This van down here has a fire on the side of it. What's burning? And if you say falling debris that was on fire hit these vehicles, why didn't it hit anything else? And how's it, under the vehicle? It's just very strange. His park place is several blocks north. Now here's John's boat experiment. Well, what it shows is when he turns off his gizmo, then the boat lights up with weird fires. And the car's lit up right after the tower's demise, not during, right after, as though it was right after something got turned off. This is another interesting, at the WTC, how this beam curled up. Actually, that was right across the street. That was in Banker's Trust. These are John Hutchison's samples. Notice there's no creases in the corners. I should have found the picture of him holding this one like this. Yeah. Vitamins? But it curls up like that, like at room temperature. And this is a video that hopefully will run. There we go. It wiggles back and forth. Now watch this thing. It's going to come apart in here. It's starting to come apart. Weird things happen. Some other weird things that happened were roundish holes in the outer pane of windows. They weren't necessarily through both panes. That's strange. Throw a rock through a window, it breaks the window because the window is brittle and it bends, and brittle materials are weak in tension, so it shatters the glass. So how do you get a round hole without cracks running out? Turns out somebody replicated that very thing. This is my analogy saying, okay, if you drop a rock in a pond, it ripples outwards. Maybe something like that is what ripples outwards with longitudinal waves that causes the glass to break in a rounded pattern. Now let's think about hurricanes. What do? Well, Hurricane Andrew drove this 2x4 through a tree. Piece of plywood. And with tornadoes, I'm sure you've all heard about straw through trees. It's not because they're flying fast. Something weird is going on. There's John Hutchison's sample with a butter knife in a piece of aluminum. He also has one with wood in the aluminum. If the aluminum's hot enough to melt, the wood would have burned up. So it's strange. Now, when I found these, you can see the blow-ups. I wondered, why on earth would the car door be peeling split thickness? It's not a laminated structure. Didn't know what that meant, but it was definitely a category of data, and I put it aside. Later, when I found John Hutchison's work, wow, he can peel open extruded aluminum. That's not laminated, it's extruded. And we have these coins from the World Trade Center. People like to say they're melted together. I point out that zinc melts before copper does. It also boils before copper melts. So that would likely explode, but it's one of the lowest, zinc is one of the lowest melting point materials. So what gives? Why is this stuff stuck together? And this is the only surviving file cabinet. It's from Ben & Jerry's ice cream store. Here's the piece of wood embedded in the aluminum from John Hutchison's work without elevated temperature. Same with these. WTC 6 with these cylindrical holes in it. Well, here's John Hutchison's aluminum sample with cylindrical holes in it. It's as though there's a pencil line in space around which material at the same radius is dustified. And if you had a lot of those vertically here, you would end up with dustified cylindrical columns. But there's no way you could get a drill in there and turn it sideways. It's parallel to the surface, and it just starts right here. The end of this bar is solid. Let's look at some other similarities with hurricanes. Kind of like a big Tesla coil. And come to think of it, ahead of a storm system, people feel the storm coming. Birds know to head for cover. You can feel the static field ahead of the storm. Here's another thing about storm systems. I don't know if this needs a click or not. This is from this past spring in Texas, where there's a bunch of tornadoes, and you had flying trucks.
As it went across a transport company, trees flying through the air, semi, the trailers, there you go, a couple of semi, look at that, the beds of the trailers twirling around in the sky and then dropping down from at least 50 feet high down into the ground. We saw trees, there goes another semi.
And it's spinning.
It's spinning, down it comes, bang, lands on its nose right down at the ground. Big piece of a tree there that just got hurled up, I believe it was. So certainly we have seen a destructive tornado on the south side of Dallas, still within parts of the area near south of Grapevine, north of Arlington, a possible tornado in the Dallas-Fort Worth Metroplex area, as well as over on the east side of Dallas, in toward the area around the Mesquite area, just to the west of Mesquite and east of Dallas.
Those are flying trucks. I would say that's anti-gravity. It's not a vacuum. And people who've been picked up in funnel clouds can still breathe. Remember we saw before where people had been levitated during WTC2's demise, or WTC1's. So here we have also the front of Bankers Trust. This was the only WTC building that was severely damaged. It wasn't destroyed that day. They actually repaired it. Once they repaired it, they started taking it apart. Huh? They got it down to this level where they had repaired it in deconstruction there. When they got it down to that level, that's the area that had been repaired. It looks like it's been at the bottom of the ocean for 100 years. Extreme degradation. And it makes one wonder, was the building continuing to disintegrate, and that's why they had to take it down after they repaired it. And it took them 10 years to take it apart. Now we're going to look at tritium. Kind of interesting. It's usually something that comes from nuclear reactions, but here we don't find any of the ionizing radiation that you get with nuclear reactions. Some aluminum with holes in it. Material is changing. This was a sample of dust from the Bankers Trust, that one they decided to take down. Look at all this zinc, the before and after. Like 3,500 times as much zinc from the control sample. Now we're going to look at John Hutchison's sample. He's got, just look at the relative amounts. You have a lot of copper and much less zinc. This is for brass. And the affected region, you have about equal amounts of zinc and copper. Whoops, didn't mean to. Equal amounts of zinc and copper there. So, okay, if it's heat, with zinc having a much lower, it boils, it melts at 419 or 420, where copper melts at a much higher temperature. Zinc boils before copper even melts. So we don't have less copper because of heat, because the zinc would be the first to go. What's going on here?
At Texas A&M, a group led by Professor John Bockris, who is widely regarded as one of the world's greatest electrochemists, reported finding the hydrogen isotope tritium, a key signature that some unusual nuclear reaction was going on.
The first thing was this thing called tritium, which is a sub-form of hydrogen which should not exist except in extremely tiny quantities. We found that by working these cells of Fleischmann and Pons containing lithium hydroxide and deuterium oxide, that we could produce this tritium in great abundance, let's say at 10,000 times more than it ought to be there, as it were. And let me stress that we couldn't do it every time, but about one result in 5 or one result in 4, and eventually we worked up to 2 results out of 3. We could produce tritium. That was the first thing, and in a way it was the first clear proof of the phenomenon.
And but the most important and unbelievable phenomenon at that time was the observation of tritium.
Back at Texas A&M, Bockris's group found themselves under attack. Science magazine writer Gary Tobbs wrote a stinging article that insinuated that someone in the group had spiked the samples with tritium. Although unfounded and eventually proved untrue, the allegation effectively dampened Bockris's remarkable claims.
But I think the main part was that I had done work which was against the paradigm, and that was what they were really upset about. The people had laughed at it and said, "What the heck are you doing, trying to disprove the laws of nuclear physics?" And of course that's exactly what we were doing, and succeeding, you see.
The tritium work was the first indication to me that there was a reality, and then Claytor at Los Alamos also got positive results, and so did Howard Menlove. And they're people that I respect and could talk to personally. It became fairly clear that there was a very strange phenomena occurring here.
There are also, in similar experiments sometimes, and rather dissimilar experiments sometimes, evidence of an anomalous nuclear process.
However, it is conceivable that there may be a process even more powerful than nuclear reaction that physics does not yet understand. That is the mystery of cold fusion. Yet as early as 1992, cold fusion experimenters began reporting unusual appearances of trace amounts of different metals such as copper, silver, chromium, and zinc when examining their spent cells. Rechecking for possible contamination, scientists like Bockris and Miley confirmed that indeed new metals and isotopes were being formed, transmuted, during the process which produces excess heat.
Kevin Wolf made many measurements of tritium. Then he got some even more astonishing results as early as '92, which were these transmutational results, the metal forming another metal inside the electrode, you see, which was super anti-paradigm. You know, there's that dreadful word alchemy, which we mustn't use, but it was a form of that in a way, that it was creating new metals, you see.
We see transmutation phenomena. We see helium-4 production. We see a range of methods of getting the excess heat. The writing is on the wall. The fossil fuel age is about to end.
The sword of this panel's condemnation struck with speed and brutality, ignoring the facts in a blind rush to judgment.
Hot fusion physics people have been very vigorous in their denunciation of this being called fusion.
Right away, reports came in of excess heat, much too large to be from any chemical reaction. Laboratories from Texas to India confirmed the presence of tritium, a vital determining feature of a nuclear reaction.
Within 2 or 3 weeks, we got the first results, and several groups started saying, yes, we are seeing excess heat, and but the most important and unbelievable phenomenon at that time was the observation of tritium.
This was a discovery perhaps as significant as the Wright brothers' first flight at Kitty Hawk.
There are also, in similar experiments, evidence of an anomalous nuclear process.
In the free-for-all that followed the cold fusion announcement, hot fusion proponents drew the specious conclusion that cold fusion must work like hot fusion. If Pons and Fleischmann are alive, they contended, then their results must be faulty, since the neutron radiation from the fusion reaction would surely have killed them. They refused to consider that another form of the same process might be at work. In the years that have followed, the cold fusion process has repeatedly produced not only heat energy, but also nuclear byproducts such as tritium and the ash from a nuclear reaction, that all-important indicator of nuclear fusion, helium.
It's clearly not possible to produce helium from a chemical process. The only possibility that remains is that the helium is produced by a nuclear process. If the helium is produced by a nuclear process, then necessarily there will be an associated release of heat. Having seen the effect with my own eyes, the claims from a few that this is impossible, inconsistent with all known laws of nuclear physics, these suggestions are in fact irrelevant.
That well said. But notice how important the tritium was in this, and they thought it was a fraud because they didn't find the other things that usually go with fusion, with hot fusion. There wasn't the ionizing radiation, but there was transmutation too.